right, for number 34, so suppose the people in a certain city are catching colds. It is observed that after 1 week, 40% of the people who were sick are still sick. Of the people who were well, 30% are sick after 1 week. Construct the transition matrix. So basically, you've got it when you're starting to be sick. So the initial time, and then what happens after 1 week. So when the initial sickness started, some people were sick and some people were well. And after a week, same thing, some were sick and some were well. It says that after 1 week, 40% of the people who were sick are still sick. So sick the first time, sick the second time, that was 40% or 0.4. Of the people who were well at the beginning, 30% are sick after 1 week. So well then sick is 30%. Each row has to add up to 1. So sick then well would be 0.6, and well then well would be 0.7. And that would be it. That's your transition matrix. On number 35, it says from a group of 3 men and 4 women, a delegation of 2 is selected. What is the expected number of men in the delegation? Well, at the most, you can have 2 people. And there are 3 men, so we know we have enough for that. This is called the expected number. And basically, you take the number times the probability of the number. Sorry about that. Let me do it a little bit quick. The number times the probability of getting that number. Basically what you do. So if I want to pick 2 and I've got 3 men to choose from, I know that I can pick 2 men. But maybe I just have 1 of those as the men. Or maybe I don't have any men at all. The parentheses I'm left there is for the probability. So I take the probability, to get the probability, I'm going to take the probability of getting 2. Well, that means that out of the 3 men that I have, I picked 2. And out of my 4 women, I don't have any. Now that's just going to give me a number. I want this to be a probability, so I need to have something in the denominator, and that's just a combination of any 7 to choose 2. And so I get a value for that. And that is 1/7. Then I'm going to do the same thing for the probability of just getting 1 man. And the probability of having 0 men. It's pretty much going to look the same, except the number of men and the number of women are going to change respectively. If there's 1 man, that probability is 4 7s, and the probability of 0 is 2 7s. So you multiply that all out, add them together, you get 6 7s, which is approximately 1, because you can't have 6 7s of a man. For number 36, this is where we get to pivot. So we have to make some equations and use slack variables and so forth. So the first thing I'm going to do is take each row and I'm going to make that into an inequality because I have to have a maximization equation. So that would be 9x sub 1 plus 17x sub 2 plus 16x sub 3 is to be less than or equal to 1. The next row, 18x sub 1 plus 13x sub 2 plus 15x sub 3 is less than or equal to 1. 9 x sub 1 plus 10 x sub 2 plus 11 x sub 3 is less than or equal to 1. And then my optimum equation is going to be maximization, or the maximum equation, that z is equal to x plus x sub 1 plus x sub 2 plus x sub 3. Now I want to take those inequalities in my optimum equation, and I want to put those into a matrix using slack variables, and I need the same number of slack variables that I had in inequalities. For the z equation, which is our maximum equation, I bring everything over to one side and set it equal to 0. So that's going to be negative x sub 1 minus x sub 2 minus x sub 3 plus z equals 0. So that's how I'm going to put that in my matrix. So I'm going to have a column for x sub 1, x sub 2, x sub 3, then slack variables for each one of those, s sub 1, s sub 2, s sub 3, a z, and then a totals column. I have 4 inequalities and one, or 3 inequalities and 1 equation. So I'm going to fill those in. 18, 13, 15, then I'm going to put a 1 for that, for a slack variable 1, and the rest will be zeros, and the total is 1. I'm going to put in the next equation, or inequality, 9, 10, 11, the third, I'm missing one. I'm going to back it up just a little bit because when I was filling this out, I couldn't see the top. Let's try this again. 9, 17, 16, 1, 0, 0, 0, 1. The second equation, 18, 13, 15, 0, 1, 0, 0, 1. The third inequality, 9, 10, 11, 0, 0, 1, 0, 1. And the final one will be negative 1, negative 1, negative 1, 0, 0, 0, 1, and 0. Mark off that bottom row there. So remember, to pivot, you're going to look at the last row, and any negative entries, you're going to have to pivot some number in that same column. And so you take, I'm going to take that very first column, since they all have the same negative, which is negative 1. And then for each entry, 9, 18, and 9, you take the total and divide that by the entry in column 1. So I'd have 1 9, 1 18, and 1 9. And so that would make 1 18 the smallest entry, and I would pivot there. So pivot, pivot, pivot. You're going to pivot until there are no negatives in that bottom row. And we're not worried about anything except the z when we get done. We want to know what z is. And you'll take the z, and you'll have the totals, and you'll really be looking at this entry. And so it'll say z equals, if you've done it correctly, it'll say z equals 13 over 189. Now z is not the value that you're looking for. We actually want g, and g is the reciprocal of z. So we're going to take our z, flip it over, and and divide that out. And that's going to give me my value is 14.5. Number 37, a multiple choice test consists of 60 questions. Each question has 4 possible answers, of which one is correct. If all answers are random guesses, estimate the probability of getting at least 20% correct. This is kind of a sneaky one. We want to do, this is where we're going to do the, okay, we're going to do the normal CDF here in our calculator. Which takes a range from the z-score of the first z-score to the second z-score. That's what we're going to do. So we got to figure out what this looks like. We have a multiple choice test. We have 60 questions. So the number of questions is 60. From that, we want to find the mean and the standard deviation. So the first thing we're going to look at, besides this is a number, is the probability. We want to get the probability of getting a correct answer. Well, it says that there are 4 possible answers, so and only one of those is correct, so the probability is 1/4. And then we're going to find the mean, which is the number times the probability. So 60 times 1/4 would be 15. So the mean is 15, and we also want to do the standard deviation. The standard deviation is the square root of n times p times 1 minus p. So that's going to be, we already know n times p is 15. We're going to take the square root of 15 times 3/4 for this one. And we get a standard deviation of 3.35. Approximately. Now we're going to take that and we're going to think about this in terms of z-score and how we do that. First of all, we need to know, well, we want to get at least 20% correct. The probability of greater than or equal to 20%. We really need to know what 20% is. So to do that, I'm going to take 20% of 60 and get a value for that, which is 12. So that tells me that if I get 12 or more out of the 60 correct, then I will meet that group. So that's the same as saying the probability of 12 or more. This is where it gets kind of sneaky. If I'm looking at the normal curve, okay, this is the mean right here, which is 15, and I want 12 up to 60. So anyway, yeah, anything from 12 up to 60, and I'm going to meet that. And so on the curve, I'm looking for all of this, which is basically the area of all of that. To enter this and look at my z-scores, what I want to do is give a value to 12 and to 60. 60 I'm not so worried about, but I do need to give a value to 12. So I'm going to say, I can round up. I'm going to make that 11.5, and I need a z-score for that. All right, so if I take that 11.5 and I find the z-score for that, the z-score is going to be 11.5 minus the mean, which is 15, divided by the standard deviation, and I get approximately negative 1.04. I'm going to use that in my normal CDF, and I'm going to go from negative 1.04, that z-score, comma, basically to infinity. I don't want to actually stop at 60. So think about that infinity, and how I would write that is 1 times 10 to the 99. You can also do 1 to the, or 1e to the 99, and basically that's how you say infinity on your calculator. If you do that, you should get 0.8508 on your calculator. Number 38, you just had to give decide what the truth value is, whether it's true or false. For this one, 6 does equal, so it says false, then true. When I have false and true, then it's true. The only time that it's false is when I have true and false. And then the last one, well, last couple of them, we have to give a negation. They tell you exactly how to write the negation there. And then, let's back it up. And number 40 says 4 accounting majors, 2 economic majors, 3 marketing majors have interviewed for, there's 5 positions to fill. And we want to find the number of different ways that 5 can be hired. We're going to pick 1 accounting major. We're going to pick 1 econ major. We're going to pick 1 marketing major. And then the 2 remaining positions are just going to be kind of filled at random. So we need an accountant, and we have 4 to choose from for that. We need an econ major, and we have 2 to choose from. And for marketing, we have 3 people to choose from. Now it says we have 2 remaining positions. It doesn't say what they are, but we're going to take the people that are left over. Obviously, this is how many, 4 is how many accountants we had to choose from, but we only filled 1 position. So we're going to take 3 away from there. We had 4 and 2 and 3 all together. That was 9 people. We used 3 already, so that leaves me with 6 for the 4th position. Once that one's filled, then I have 5 more people to choose from, and I would multiply all of that together. And you get 720.